So, if you were just watching my most recent video, which you may well not have been, but where I came from just before now in my time sequence is I was looking at this Codesters script, which is essentially Python, but very rich with added features such as the ability to create a Scratch-like environment with little sprites jumping around doing whatever you want. So that's not part of sort of standard plain vanilla Python. This, you could say, is an enhanced world. If you recall, what we can do with this is generate a bunch of pumpkins. I still have Frankenstein in the background and have each one twirl and shrink. That's all that really goes on in this environment. Oh yeah, the bats. We get some bats coming in. So you may be wondering, what's life like after Codesters? Like, where do we take it from here? We started with a block-based language. We moved to a more lexical, typing-based language. And now we're going to jump ahead and sort of look at plain vanilla Python. Now on the left here, you see a program or a script, kind of like we have in Codesters. This area here is sort of where we write our code. The analogous window in this Spyder IDE that comes with Anaconda distribution of Python. The analogous thing is on the left here, a place to write a script and then save it. And then we can go out to, if we want, we can go out to the bash prompt or operating system prompt or shell. That's not it. That's Camtasia for making videos, which is what I'm doing now. Let's go out to the shell. So here we are at the bash shell. We can run this Python program called play, or is it primesplay.py. We're going to show you the source code of this at the end. Just go through it briefly. But what it does is it asks, is this number prime? And then you put a number after it. It has to be a positive integer. The fundamental theorem of arithmetic says that, okay, if you're not prime, you're going to have prime factors. So this says false, meaning I'm not prime. So 517, what are your prime factors? Now, if I just type this, it's gonna bomb because there is no factors that's in bash. What I'm really running is a Python program. I'm feeding this script or module called primesplay into Python, the interpreter. So Python is like eating this, primesplay, and primesplay in turn is eating this factors 517. So I'm going to get back the factors of 517. So that's using my program. Now what does it look like to develop that inside of Spyder? Well, the code for this primesplay is in another tab. And what you'll see is it's essentially two different functions which we've tested already. There's the isPrime function. Now you can see how it begins with this keyword def on line 16. That's kind of the signature that I am a function. And then the code that belongs to that function is indented. Usually 4 spaces. It's a style issue how deeply you want to indent, but 4 is kind of expected. And then we have what's called the doc string, just a triple quoted string. It's not given a name. This is going to play a role when you ask for help about a module. And then we have the actual source code, and we see that there's a return true on line 26 and a return false. So this returns from multiple places, but when a function returns, that means it's finished, it's done. However, there's a subtlety here that provides some continuity from one use of the function to the next, so I will get back to that in a second. Let's just look at factors. Factors, it's really interested in only having integers as input, and it will give a -1 as a factor if it's a negative. So I don't restrict this particular function to only eating positive integers. It can eat negative integers, and it will give an intelligible result. The primes will be there, -1 might not be there, so I can run this right here in the REPL, the interactive thing that comes on the right side of the screen. So I'll just do like factors 517 like I did before, but here I can just get away with saying factors because it's in my namespace. Could talk about all that another time. So this is what adults, you could say, Python looks like. And down here is where I'm actually parsing the command line as we saw out there in Bash. When I actually feed my values to Python at the command line, I have to have code to get those little strings and interpret them in my code. And that's what's going on down here. This is basically saying if I'm the mouse being eaten by Python, this whole script, if I'm the top level module around here, then I need to check the command line by importing sys, which is going to give me awareness of the surrounding operating system. And I'm going to look for those things being passed in. And if nothing's passed in or something goofy's passed in, then I'm just going to type the help me, or I'm going to run the help me function. So let's put something goofy in. Let's just say, goofy here. If I can get the typing correct. I mean, already it's goofy, but let's just mess it up and see what happens. We get all this printed out. This is what I intend to print out when people need help, okay? So the source code for that is all contained in the script on the left. So there you go. This is kind of what adult Python looks like, and you can see how we got here over the years maybe using these steps along the way. Some of us came this way, some of us didn't. Now we're here in the Spyder IDE. Now I'll end with kind of a commercial for Anaconda, which is where I got the Spyder IDE. And let's see what that looks like. This is the current Anaconda Navigator screen. I download this for free, and there we go. We've got the Spyder there, and Jupyter Notebooks, worth many other videos and other things. It's a wealth of free software. So by all means, check it out. Then also Python.org is there for you to get a plain vanilla Python. You can have more than one Python installed. So enjoy if you're new to Python. Otherwise, what I'm telling you is probably not news. All right. Have a great rest of your day. We'll talk to you soon.